a 4 kVA 400 by 200 volt single phase transformer has resistance of 0.02 per unit and reactance of 0.06 per unit. The resistance and reactance referred to high voltage side are. So we will see how to do the problem. First we will write down the information that is given, right? So it is a single phase transformer, and what is the kVA? It is 4 kVA, and the voltage on the primary is 400 and on the secondary the voltage is 200, okay, and the impedance in per unit is given. This is 0.02 plus j 0.06 per unit. Now what is it that we want? We want the resistance and reactance referred to the high voltage side, okay. Now the per unit value, this is equal to what? It is equal to the actual value divided by the base value. Now for a transformer, you have different base values on either side of the transformer, right? For primary side we have a different base value, on the secondary side we have a different base value, okay. So the per unit value, it is equal whether it is referred to the primary or the secondary side. Now actual value referred to primary if you take, then you have to take the base value of primary, okay, and if you are taking the actual value referred to secondary side, then you have to take the base value of secondary side, right? Now what we want is the reactance, resistance and reactance referred to HV side, which is the primary side. Primary side is the high voltage side. So we want the actual value referred to primary. We have the per unit value. We need to have the base value with respect to the primary side. So we can write the primary side base value, okay. So what will be Z base? This you can write as the voltage base divided by the apparent power base. This is equal to 400 square divided by the apparent power is going to be same whether it is primary or secondary. So it is 4 kVA. So this you are going to get as 40 ohms. Then what will be the Z actual referred to primary? This is equal to the per unit value into the base value, which is 0.02 plus j 0.06 into 40. This you are going to get 0.8 plus j 2.4. This is the required answer. A 200 volt by 100 volt 50 hertz transformer is to be excited at 40 hertz from 100 volt side. For the exciting current to be the same, the applied voltage should be. So first we will write down the given information. Here the transformer is 200 volt by 100 volt, but the source is given to the secondary side, okay, and it is given that it is a 50 hertz transformer, and if it has to be excited at 40 hertz, so we will take this as F1 and F2 we will take as 40 hertz. In both the cases the exciting current should be the same, okay. In that case, what should be the applied voltage? Now the applied voltage, this we have the expression for applied voltage. What is it? The RMS value, root 2 pi Fn phi m, okay. Now the exciting current should be the same, implying that the flux is same. So phi m is going to remain same and n is also going to remain same, the number of turns, okay. Root 2 and pi, they are anyways constant. What is the variable that is changing here? The frequency. So if you write this as V1 F1, for F1 frequency V1 voltage is required. Now for F2 frequency, what is the given, what is the required voltage, right? So from here you have V1 by V2 is equal to F1 by F2. V1 is given as 100 volt, right? For 50 hertz we need 100 volt. So now for 40 hertz, what will be the voltage? So this, if you calculate, you are going to get V2 is equal to 80 volts. This is the answer. A 2000 by 200 volt 50 Hz single phase transformer has an exciting current of 0.5 amperes and a core loss of 600 watts. When HV side is energized by the rated voltage and frequency, the magnetizing current is. So we will see how to do this problem. First we will write down the given information. So it is a 2000 by 200 volt single phase transformer. Now what is given? The exciting current. The exciting current is nothing but the no load current. Okay. So no load current I naught is equal to 0.5 amperes. The magnitude is given, right? And the core loss is given as 600 watt. From here you can find out the core loss current. Okay, the voltage we know. See, we have the magnetizing reactance and this is the core loss component. Here IM is flowing, here IC will flow and here I naught will flow. So we can approximate this as the applied voltage V1. So now if the core loss is given, what is the core loss? V1 into IC, right? So V1 into IC is equal to 600 and what is V1? It is 2000, right? So the core loss current you can find as 600 divided by 2000. This you are going to get as 0.3 amperes. Okay. Now you have IC you know and you know I naught as well, right? How can you find out the magnetizing current? We know that I naught is equal to root over IM square plus IC square because IM and IC they are in quadrature, right? So once you know I naught and IC, you can find out IM as root over I naught square minus IC square. So if you calculate how much you will get? 0.4 amperes. So this is the required answer.